Okay, good morning. It's still a little bit of morning left. We're happy to be here. We're from Unifying platform, and this is Hogne Titlestad from the chief architect and founder of Friend Software. And my name is Paul Lassa, and I'm the Chief Product Officer. And we ask a provocative question up front here today that hopefully we'll answer as we go through the talk. Now, we have a fair amount of, it's a fairly extensive platform, and we have lots of material, so we're going to only raise the surface right now. We invite you anytime. We invite you to join us, come see us at our booth, and we'd be happy to show you more, explain more, and we've got a wealth of resources on our website that we can show you. So, question of, does the web need an operating system? Well, we have something that we call the Friend Unifying platform, and it's a new technology that we believe is a vital step forward, similar to some of the big steps we've made in the past in computing, such as Linux, the internet itself, the open source movement, the standardization of browsers, and more recently, Docker. The key point to notice in our talk and in our product, it's right in the center, is unifying. Unifying, it's not unified, it's not unified, it's unifying. We think that we started our mission a couple of years ago, and we think it will be perpetual going forward. We have a technology that will continue to unify both existing technology, legacy technology, and new forms of technology that may come on the scene. It is a system, a way of thinking that we can make things work together better. Okay, a brief outline of the talk is we'll have a quick overview of the problem statement, and then we'll say, what is a unifying platform? We'll put forth what our solution to solving these problems will be, and then we'll go through a little bit of detail on the key components of how we deliver this platform. And then we'll hopefully get into we plan to get into a demo where we'll show you first a preview of the operating system, and then we'll show a demo of a live presentation of us interacting with it. And then if we have time towards the end of the talk, we can cover other topics or go into greater detail on some things. Okay. So we all use computers for a variety of different applications, such as personal reasons, business reasons. We use them at work for collaboration, productivity. We use them at home for social activities such as Facebook, reading the news. We all use Amazon or other e-commerce type sites. The web is fantastic. It's a boundless resource of lots of different things that we can do and use. And the cloud, more recently in recent years, that we're making it actually a destination place for storage, processing, and vast amounts of data. But what are the issues we run into in doing this? Well, first thing is that we know we have competing platforms. We have vendor lock-in that we all experience. And two big words here, integration and migrations. We're constantly being introduced to new technologies that we have to integrate with the existing ones. And at times we're migrating from the old solution to the new solution. And I'm sure everybody here has experience with some of the headaches that presents. As I said, any business you go to typically has a mix of old applications, old devices, old platforms, and new ones arriving. And there are oftentimes we experience conflicts among these, and we have to deal with legacy issues. There will always be a complexity of the technology. It's the nature of this business. And unfortunately, the user often has to memorize or be at the ready to switch among them and have different incantations to make things work. Furthermore, we know that in the coming years and even in the present, we have vastly new technologies coming on the scene that we expect to deal with, and that they tell us will become a big part of the internet and the web going forward, such as blockchain and decentralized technologies. We'll talk a little bit about that later in the talk. Okay, so what is a unifying platform? And is it a new operating system? Are we saying ditch all the old ones and use ours? No. We know that the web gives us a lot of capabilities, and they come in lots of different flavors, and that's okay. And standalone point tools really work well, and we find and use the ones that work for us and help us get our job done. But unfortunately, we have to use many different platforms, as I said, and many different devices, many different applications from different software vendors. And here's a list. We're all familiar with the major platforms. So luckily, there are only 2 or 3 major platforms, 2 or 3 major mobile phone platforms, and then we have applications from major suppliers that mostly follow similar rules, but there's always differences among them and difficulties in making them work together. Furthermore, for developers have to deal with this problem. Developers have to pick one or more of these platforms and try and craft a solution that works for their customers. And it's quite a challenge if a developer had to make something that worked across all of these platforms and devices and OSs. We have a solution that we think can address that. The FriendUP platform provides a device and OS independent user workspace container. This means that any applications you're using today at your business or personally, we containerize it essentially in a virtual way, and we'll explain more, such that it can live on any of your devices. It can live on your laptop, your desktop. It can be accessed on your phone, in your pocket. It can be used through AR and VR going forward. In making this a unified platform, we enable rapid application development and wide-scale deployment. Essentially, you can write once and deploy it across all of these platforms more easily than you can today. It also offers many additional powerful capabilities that we'll go into to give a user desktop experience in the cloud and offer a more streamlined way of applications delivery. We sometimes refer to this as a meta OS, and what it's designed to do is make things work across all the existing OSs and across the cloud smoothly and consistently. Now, how do we do this? How do we accomplish this? Well, we learned early on that a key part of this is that we need to adopt a mindset that the big tech giants can't really adopt. They can't be agnostic. They are selling their line of products. There's the Windows platform. There's the Apple platform. There's Android. These platforms sustain themselves, and each platform owner is interested in making it a better experience to keep people on that platform. So for us to make this work across all of those devices and platforms, we have to be agnostic. We have to say, we'll work great with Windows. We'll work great with Mac OS. We'll work great with Linux. We'll work across whatever mobile phone you happen to have. And so agnostic is a key term. We deliver this by some of the capabilities that are built into today's standard browser, HTML5 browser, and in particular Chrome. Chrome has everything, nearly everything you need for us to deliver our platform on the front end, so anyone can use it. And anytime the Chrome browser is ported to any device, be it a Raspberry Pi or whatever, that device then can live in our platform and deliver this consistency of workspace across all devices. Furthermore, our solution integrates both at the client side and the server side. And we provide a solution where this is delivered without developers having to handle the back end. Furthermore, we have the connections and pathway to work with the emerging technologies such as blockchain and decentralized technologies. And we'll talk more about that. Essentially, this gives you one workspace that lives in the cloud and you can call it up from any device you happen to be near. If you're walking down the street, you drop your PC or laptop, and it smashes to pieces, you pick up your friend's laptop, and you can call up your same workspace, everything that you use. Another key component of how we deliver this is called FriendUP, and Hogne will go into more details on that. It's essentially an intelligent web server co-kernel that lives out on the internet, embedded in the internet. It can run on our servers, it can run on your servers, it can run on Amazon, Google, or whoever. It is a portable component that enables the delivery of applications in a uniform way across the cloud, and delivers cloud apps that are scalable and can be deployed across all regions, all geographies, infrastructures, and any type of organization, small to large. And of course, it can be used personally in your home. Okay, I'm going to show a brief video here. That's a 1-minute video so you can get a mindset of what this looks like. Following that, Hogne will go through some of the key components that we have in delivering it, and then we'll move into the live demonstration.
So we'll just have to see if this thing actually gets on the screen.
Do we hit F something to get the video?
You can hit escape.
Escape. There we go.
Imagine your own secure. Secure cloud-based computer, a truly decentralized system that you can always access anywhere you go on any device within reach. With all of your most used programs, virtually unlimited processing power, and a system that truly protects your needs and privacy. You just imagined Friend. The Friend Unifying platform is the world's first open source virtual cloud computer, designed for decentralized, secure computing and built for blockchain technologies. With the rise of blockchains like Ethereum, the new internet is decentralized. The only thing missing was harnessing this power to create a full computer operating environment, until now. After 3 years of full-time development from a visionary team and based on powerful open source technology, which today is found everywhere, our free platform brings together the raw power of the decentralized network and is the operating environment of the internet. Find out more about the Friend Unifying platform at FriendUP.cloud.
Is it available now?
Yes.
Oh, is it free?
Yes.
Oh. I will try right now. Wait, thank you.
You'll go right to the website and you can download a user account, set up a user account, and start using it right now.
I play right now. Exciting.
Good. Well, wait till the end of the talk.
So then we go back.
Free cloud. Blockchain. Making a lot of money. It's good.
So, Paul was kind to introduce me. I'm Hogne Titlestad, to be best in English. I'm from Norway. And I started working on this project in about 2007 under a different name. Back then it was called Anubis. It was a spin-off of an operating system that was quite traditional back then, but still alternative. And so this system itself has been a long time in the making, but it's just the last 4 years that we actually worked on this code base. And of course, in 2007, the browsers were nowhere near where they are today. And a lot of what has happened the last 4 years have happened as when we needed them, essentially. It seems like tech is going the same way we are, and that's probably why we're still here, and that's why we're talking here today. So, the idea is that you have a thin client and a server. It's an old idea, and actually the grandfather of the Friend platform was a system that was meant to give decentralized access, or thin client and server access, to users in universities and so on. Back when these type of systems, these cloud systems, were first envisioned, the internet didn't exist and it wasn't possible. So we've gone back and looked at some of the ideas they had when it was not possible to create those systems, and we've taken that into the current time. Not going to go too much into that, but we're quite interested in history in our company, and if any of you guys want to come by our booth, we can talk as much as you want about what happened before. So once you have virtualized an entire computer, you can play with it, especially when you have virtualized it with web technologies. You have created a high-level system. Now, we do have low-level components in our system, which means that we built the brain of the system in low-level code for speed, so that we can be compatible with the 5G network once Wi-Fi is spread throughout our cities. Can happen sooner or later. We have replicated virtual computer templates. That means that our cloud computer, so FriendCore, our server, allows you to build various networks. So if you have a server installed, you can link that up to other servers, and then you can build your own closed networks. It's really good for medical industry. It's really good for various different types of companies that need security. But you also have the wide web. So that's what we're doing in blockchain. We're putting an operating system into the internet itself and making it autonomous. Now, once you have a technology like that, then the OS kernels, now we're talking multi-kernel systems, because each server is part of the brain of the machine. There you can have a user account. And the user account can be connected to a template. So when you first log in, you get a gaming machine, or you get an office machine, or a designer machine. And then you can instantiate that template to other users like you. Or everybody in your work group in the cloud joins in and they get an instance of the template that you first logged into. It's delivered through HTML5. We mentioned Chrome here specifically because Chrome has kind of trodden some of the path that we're taking. They're using that technology in Chrome OS, and when we're talking about Friendbooks, we're really talking about doing the same thing as Chrome or Google is doing with Chromebooks with this system. And that can work using HTML5. So what I realized back in 2012 was I had been doing web development for a long while. I started in 2001, and so I've seen everything from when Mac OS came out till now. And in the beginning, nobody could imagine using web technologies for anything than layout of documents. And you know, if you want to do anything interesting, you use Flash back in the day. But that has changed. And today, you could look at HTML5 as, or the engines rendering HTML5 applications as kind of on par with what DirectX does for gaming. So it's a rich media engine, it's super fast, and now with WebAssemblies you can really do anything you can imagine. And being on the network, it's the perfect remote system where you have a brain somewhere and then you have the interface somewhere else. That's why we use that. The workspace becomes as customizable as a website. So essentially, the layout is separated from the logic in the applications. So this is how fantastic web technologies are. If you have an application written in JavaScript, and then you have some logic in the cloud, then you can change the interface completely. what we see now is that with web technologies, you can deliver VR experiences, applications that run on mobile and that runs on the desktop, the same code, just different layout instructions to the technology. And so the entire workspace can be white labeled, you can change it to be something that represents your company, and you can decide which apps you want to have available, and you can customize how you want to solve the storage problem. So you can have friend cloud drives, we also provide our own DOS drivers, or you can tap into Google. Or you can use blockchain technologies like IPFS, for example. We have a driver for IPFS, which will be available soon, and then you don't have to sign up to any vendor. You can just start storing your movies directly in the cloud. It's back-endless. That means that the system is built like an operating system. It's very much like Apache. If anybody is not a developer, doesn't know what that is what runs pretty much probably 40% of all websites in the world. Now our server is on par with that in performance. It has about, on a medium server, you can have 7,000 requests a second, and you have sometimes sub 1 millisecond latency for the requests. But it's built like an OS. That means it has file management built in, writing and reading from files and structures. It has processing. It can do computation, various things, and it does this through a command language that will be understood by everybody who is a little bit deeper into operating systems. And that's built right in, and still it performs like Apache. So it's not just uploading static files, it's actually thinking. And that means that when you use our JavaScript APIs, you don't actually have to poke the server. You just use the APIs as if you're building a client-side application, and our APIs plug that into the server cluster that you're using. So we also allow the developer to tap into the client-side resources, so the stuff that's actually accessible to you through the browser. Now there's happening somewhat of a revolution there. You have even got USB integration and various different things that you can do with the browser. And what we're doing is that we're making the APIs for that in the desktop environment that you're using on your notebook or the mobile environment you're using on your phone. So that means that, for example, through WebRTC, which is mostly used for Google Hangouts and those type of applications, you can also use that as a data channel between the different users as a VPN type system to push encrypted data between users without ever going through a server. So that's specifically for security purposes, but it also allows the different applications running on our different desktops to actually use each other's resources in a network without going through the server system. Then we're doing something interesting for the blockchain. So this has been built in the last 4 years, and it's working. But the next step is to go into blockchain. Because we need trustless user accounts, we want you to essentially go to the internet, make my computer, and that's permanent. And then if you go to China, if you go to Russia, if you go to the United States, or if you go to Africa, wherever you are, you have a local access point. That could be with a small shop in, I don't know, Kenya or wherever, and you connect there, and then you get your user account through Ethereum. And then that connects you to all the resources you have, which are replicated throughout the node network, and then you get your computer wherever you are. And it's always there, always on, always doing stuff for you while you're somewhere else. But what we're doing with this is that we're making our APIs so that you can choose. If you're not into blockchain, and if you're not into decentralized computing, the APIs are the same. This is an operating system, so we are building drivers, high-level drivers. And so when you're building an application that uses some of the, for example, databases or storage or compute, then if you change from the blockchain driver to, for example, AWS's infrastructure, then you don't have to change your app, you just change the driver configuration. And that's part of our mission, to transparently skip between blockchain and non-blockchain technology. But when you're on the Friend network, which we'll come back to, which has connections to cryptocurrency and blockchain, then as an app developer, you can choose to do transactions either in fiat money. That's why we have a Norwegian company that allows developers to have invoicing services or use normal credit card transactions. Or you can use the autonomous system connected to the blockchain. So you can use the token economy to do micro transactions for in-app services, or just to sell your application or service. So we're building an entire store for this that will be kind of like a skin on the APIs, because you will be able to use those transaction APIs to build your own stores. Because we're going to have our own one in our Friend Sky, which is our cloud platform. Today we have about 3,000 users there testing the system, and we're turning that into an open-ended cloud solution on a decentralized way. FriendCore, I've gone a little bit into it, but what I can mention is that it's very extensible. If you have one FriendCore downloaded, you can customize that with your own modules, and so you can also use it as a generalist server and kind of rig it up to do whatever you want to do, for example, on a Raspberry Pi or in a do-it-yourself scenario. It's very extensible, all the APIs are open. We have documented all the RESTful commands. They're available on our website, so something you can look at. The Friend network is probably the biggest thing, because inside this cloud computer, the internet you're using there, a lot of people are like, okay, I'm going into this desktop environment, where's the browser? And then they forget for a second that they're already in the browser. So they can just open another tab, but they feel like opening it inside the tab. And of course there are some technology restrictions there that doesn't allow you to do that because of security. So of course we do that through Liberator, our Windows module. So we just give them Firefox inside the browser tab. But that's not the whole idea. So inside the Friend workspace, unless you want to use hacks, extensions, and Windows applications, which we also offer, it has its own intranet inside that is between the different nodes. It has a peer-to-peer intranet, and it has a node network intranet that connects all the users that activate the Friend network and all the servers. And so that way you can create intranets that are closed from the outside and offer services inside, or you can make an expansive online extranet. So this has a lot of opportunities. The whole entire thing is open sourced. So we do retain a commercial license, because we know some people may not be able to adhere to the open source licenses. So we allow linking and packaging for those who need that. But for developers, they can just go in, they can download everything. We used 2 years to educate our investors and contacts so they would really understand the open source economy, which is actually probably the precursor to everything that's now happening in blockchain and cryptocurrency. The open source movement was what started all that. And to get into that mindset is very important, because every time you create an open source product, you're making a new market, which can room a lot of other products. So it's all open, we're all into freedom. Please check us out on GitHub. Okay, so we're going to do a little demo, and then if we have some more time, I think we're all right on the clock. Then we're going to go a little bit deeper with some graphics and slides. We're going to talk about a little bit about how we see the decentralized networking infrastructure going in the years ahead. As you all know, there's a lot of regulation happening right now, and as a developer, being inside this new economy, it's a little bit strange, because we're out before the authorities could catch up. And now they're kind of running after us, trying to figure out how to make a framework that will fit with this thing that has already manifested in front of them. And that means that they will never be able to regulate it fully, because it's a runaway effect. But they will do some force majeure actions to try to just push it into a framework. And so that could also be a little bit interesting to go into. Let's see. Yeah. All right. So I'm now on not my computer, which is fine. That's why we have this system like this. So we're going to go full screen, and I'm going to go log into my account. So this is how it works. Whether you instantiate a new computer or log into your own one, the entire client-side operating system loads like that. And then it's running on your system. And now it's connected through HTTP and WebSockets and WebRTC to the server and eventually other services that are out there. Many people think this system looks a little bit like Linux, but you can configure it. We have some different templates. So I'm going to log into some other ones. Let me see. See if I remember. So, for example, this is a little bit different look. A little bit more like a Mac. Of course, this will be possible you can choose how many skins you want to use on this thing. And then, of course, we could try another one. Let me see. So, if I remember all this. And this is more, I don't know, masculine, more like, you know, for people who are more into cars and coding, I guess. So you can create any type of field. You can make it behave exactly like a Mac, like a Windows machine, or like something new. First I'm going to show, we have a chat program that we built using WebRTC. So I'll let Paul invite me.
Live invite received.
And you know how that goes. So the system uses WebRTC, and this was actually one of the first things we built to start playing with that technology. And that's when we started pushing data. And we thought, why should there be a difference between video and data? And then once we started doing that, a lot of interesting things happened. This is one of our showcase apps. So as an operating system developer, it's not really, you don't really want to make apps. If you're into operating system building them, you want other people to do that, but of course you're in a peculiar situation when you're building something and are trying to convince people. So FriendUP has actually become a very capable video conferencing application where you have live conference rooms, email invites, and it works on phones, it works on everything Friend works on. And probably this year it will also work on iOS. They've been very late in supporting WebRTC, and we think that's going to happen. Of course, we have a marketplace, which is now in beta, which is the runner-up to the full Friend store. So at the moment, it shows you what's available in your cloud computer network. So you can browse through that and activate and launch different games and whatever else you want to do. This is also where you publish your own stuff. So if you make something, if you make something in Friend, you can package it. So we have an integrated development environment in Friend. which allows you to build full applications, package them and install them in the cloud, and then other people can install them and test them. And that's all going through drag and drop. We also have started playing with visual editing, just simple things for now. It's a US keyboard. And we also have something we might show a little bit later, which is called SAS, which allows you to through the server network, make a concurrent connection in your single user app and link it up to multiple users so that they are actually working on the same application over the network. We might show some of that at our booth. If you want to come over, we can show you some whiteboard and different things. So see time is moving here. So I'm going to do a little bit about the system. So like for example in this template here, there's no system because she would come screaming to tech support if she would have this system drive running that she didn't know what it was. Users are scared of unknown objects, and that's why you can box down the system and customize it to users' needs. But if you're a more advanced user, you might want to use this thing. It has our documentation inside, and it has devices. For example, this system only has one processing core. It has a heap of DOS drivers. DOS drivers are high-level file system drivers that connect to the low-level drivers in our core. So you can use those to access all kinds of storage space. Actually, if I go on my account here, and if I would want to add more storage, I could add Google Drives and IPFS and different things to my system, or connect to other friend cores that are running outside on the internet and mount those disks here. Also, if I'm in with multiple sessions, they come up here, so I can see how many times I'm logged into the same account, and then I can communicate with those through sessions. Actually, if you look at FriendUP, there's programs in Friend also become virtual disk drives, so I can actually log into the chat. I can go in and look at functions and, for example, quit the application by running functions that's inside the application. You can also share those application disks over the internet, and then you might quit my application. So it's a friend nuke. We also have a scripting system for this. We can go really deep, but it won't fit in our time schedule, so I'll just move on. I think we go to back to the slides for a while now. Yeah. Last thing I can say about that is that we have all the email and all the different applications. We've been running this as our own intranet for 2 years for everything, all our video conferencing and emailing and chatting and storage. So there's a lot more to show. So this is an architectural slide of Friend, how it looks like. So as you can see, the host OS is on the bottom of the stack, and then Friend Core is started. It doesn't have to be started as root. It can be started as an user space. So it depends how you want to customize the setup. It has some. This one is written in C code to be linkable with as much as possible, and also for speed. So we're kind of low-level freaks. We love seeing that it uses or has a low memory footprint, and that it uses as little CPU as possible when you're not having heavy load. The libraries are also written in C for the same reason. So the libraries allow you to link up. Eventually, Friend Core will probably become a Linux module to extend the Linux kernel into becoming essentially a Friend operating system.
Hogne, is this a virtual machine?
Yeah, so there's a distinct difference between a virtual machine and a virtual cloud computer. So a virtual machine is essentially simulating an entire PC with graphics cards and everything. A cloud computer is meant to be a virtual or something that looks like a computer, even though it's thousands or millions of resources that are just scattered, IoT devices, whatever. So it just takes all of that, networks it together, and presents it as if it was a computer. This was also the thought of Ethereum and many other projects, is that, you know, the internet is there, it has all the resources, why not link it together and then abstract it so that you can actually use it without running around everywhere and poking every single computer. So we have a different perspective than Ethereum has, even though we love what they're doing and we're going to use it, is that we're more user-oriented. We like to say that we're putting the user in the driver's seat. And so that's why we have this desktop environment, and that's why we have JavaScript functionality. A lot of people call us the AWS of decentralized computing, and that's true to an extent, because you can fire up all kinds of resource nodes and configure that together, but we're, again, user facing, meaning that when you log into AWS, you don't really go in there to use the computers you're setting up. You're going in there so you can set up web servers to run web apps and different things. When you set up a Friend virtual cloud computer, you're actually going in to use it. That's the difference. So this is running somewhere in the cloud, or you have it in your basement, doesn't matter. When you can access that, it uploads that workspace like that. And then you have the entire operating system on your Chromebook or whatever device you have that has a browser. It has an API wrapper inside, which essentially is how we do our technology, is that this one is routing all the messaging that comes from all these different application layers. So we have, over here, we have external resources on the network, which bypasses the server. So that is when you connect directly from the web client into other web clients or external resources. And that also can be routed into the API wrapper. So when I have my system up and running and the server is going down, I can still connect to stuff from my browser and continue working. This stuff is the server domain. This is what is required to boot the whole thing.
Since we're running short on time, we'll just show a couple more, flip through showing you some of the slides. We can talk about them later, and we'll offer you an opportunity to ask some questions.
Yeah.
So I'll show the picture slides instead, but we'll talk about how we can on-ramp to the blockchain, and it's kind of illustrated by this picture here.
Yeah, this is kind of where we're going with the permanent operating system embedded into the internet. Now, we partnered with Golem a few months ago, and last month we partnered with Fluence, which is a Russian database company. All of these projects are global, by the way. It doesn't matter where they're coming from. This is a fantastic thing with what's happening in the cryptocurrency world, is that developers from all over the world have access to suddenly getting funding for projects that otherwise would never have happened. And that allows us to link up across borders and have share insights in a way we would never do before. So it's a very cool catalyst. Now what we're doing is that we're building the Store API, which is running in our network. And today it's amplified or running on a token. It's called the Friend Network token. This then connects up through the Friend Network to these various different decentralized systems. And then you can go in here, instead of going to all these hundreds of different project websites, you just go into the store and say, I want to have a new IPFS drive. Click. It's free. where you say, I want to have, you know, this company over here has a special deal with IBM that has super secure infrastructure that I'm required to use for this certain app. So I'm going to go in and use the IBM drive, buy, and then you do that with fiat. Or you go and say, I need a processor node because I have a huge Blender project I need to render. And you go and buy in fiat money, traditional money, and you go buy for, I don't know, $50. You buy access to Blender, you use it in Friend using our Liberator module, modify your project, then you render it with Golem, and there goes Golem network tokens. So it's all in one. It takes both cryptocurrency tokens and fiat. So this is, sometimes we play with some models, and perhaps 6 months later we just remove the model because it was more fun when we were making it. So let's try this one. We call it the double helix of network proliferation over time. So what we can imagine is that the next few years, a lot of people will be using Amazon infrastructure to kickstart their decentralized networks. Today, the majority of decentralized technology is running on centralized servers. And they have to, because there are not enough users in the decentralized networks anymore yet. People haven't downloaded the servers and run them so that it becomes really decentralized. But that's going to happen. It's going to happen, especially with systems like Friend, where we will allow you to just go in the Android store and click a button, install Friend, and then you download the Golem server on your phone. And you might have it on when you're loading or something like that, and earn tokens or whatever. We believe that it's going to be a change. There's going to come a change at one point where people are going to use less and less centralized server infrastructure to run decentralized networks, and where it's actually going to be decentralized. And then what you're going to see is that entities like Amazon and Google and Azure will come in and participate in decentralized networks over time. So it doesn't mean they're going away, it just means that they're going to change.
Yeah. So, quick point. We've alluded to a macro computer and using multiple nodes together, and we have a slide just after this that shows a picture of it. Essentially, anybody running this can offer their node to participate in this macro computer, and we call it using underutilized resources. So when you're at home sleeping for the night, you can let somebody use 2 hours of your processor and they can send you tokens. You can collect tokens over time, and then if you wanted to run a batch job somewhere out to 1,000 nodes at the same time and get your results in 10 minutes or so or render something like Blender, you could use your same tokens to then pay for or transact in this network. So it's similar to Uber, Airbnb. When your house is not being used and you're away, you may let somebody come and stay there for a vacation. When your car is sitting in the driveway, and you may go and use it to give somebody a ride somewhere. When your computer is not being used or underutilized, you may lend it out for others to use. And here's a quick picture. We're nearing out of time, so let's offer a little bit of questions if you have any in the audience.
Yeah.
So you guys have your core. You have your. I'm running the friend node, and then you've got your API wrapper on top of that, and then so that application API step above that. Is that so? I'm building a dApp right now, and I'm interacting with Web3 in order to connect to the Ethereum blockchain. You got your application wrapper for the Ethereum blockchain is effectively that Web3 object, right? It's your version of that for me to interact with the Ethereum blockchain in Friend. Is that a good way to think about
not necessarily.
Okay.
Because the point is that when you're running in Friend, like you saw some of the web games, they're just iframe and window managed. But in addition to that, they are connected with our messaging API. There's one application that's called PhotoP. It's an amazing application that reads PSD files, Photoshop files. It has support for masks, layers, groups, filters, the whole shebang, even Apple scripting, Adobe scripting. The funniest thing is the first app this guy ever made. So he made it to learn how to program. It's a fantastic thing. So he has changed his API now to work with the Friend API, which uses post message, if you're familiar with that. And so essentially that allows client-side integration so that this application and that application are not calling home to call each other. They're just calling each other directly through our API wrapper. So if you have an existing app today, you can just move it directly into Friend, and then you can start integrating with our APIs. Or you can load up our API JavaScript file to get access to our functions, which would then do it for you, so you wouldn't have to do all the post messaging yourself.
Okay.
If I have to...
I think he was right, sorry.
Who will ensure the security of the FriendUP apps? If I'm a developer, I publish it to your network, people start to download, but how do you ensure I'm not fixing my network?
So how we're sure that you're not perhaps giving you malicious software? Yeah. So we're using sandboxing inside the browser, and we're setting up security domains so that when you have an app, you can put apps that you don't know if are certified into sandboxes and test them out. And then once you're feeling that this application is okay, then you can run it further. That does not protect you. That's why you need the Friend Store. Because in the Friend Store, you're going to have specialists who certify applications so that normal users will just go there and they will know that the applications they install are safe.
Yeah, but it becomes like Apple mode. People have to submit to the
Well, it's just going to be just like any other app store with policies and so on. Of course, you're still going to have a undergrowth of just stuff happening. And we don't want to prevent people to distribute anything they want to on the technology because it's autonomous and permanent. But in order to fix the security problem is not really a technology problem because it always changes. The technology gets hacked. So it's actually a manpower problem. You have to have specialists who go actively into it to vet the applications and then make whitelists for certain users to ensure that they're safe.
We'd like to thank you for joining us here, and we'd be happy to continue the conversation over at our booth or on our website or we have a Telegram channel, we have GitHub, you can post messages to us. We're very available, and please do contact us at friendup.cloud. Our booth is 420, and thank you again for joining us, and we look forward to speaking with you further.